Hi, everyone. In our last example, we're going to find the PFD, the partial fraction decomposition, for this rational expression. Don't worry about the fact that this top is complicated. That doesn't hurt us so much. Our first question is this proper? Is this bottom heavy? What do you think? The degree of the top, the numerator, is 3. But what is the degree of the denominator? If you were to expand this out and write it in descending powers, what would be the leading term? The leading term would be x to the 4th. And then you would have lower order terms. But what degree is the bottom? The degree of the denominator, the bottom, is going to be not 2, but 4. Is this bottom heavy? Yes, it is. Ultimately, this is bottom heavy. The expression is proper rational. Bottom heavy in degree. And that makes us happy because we don't have to do what? We don't have to do long division. Proper, bottom heavy, good. All right, factor the denominator over the reals. Well, we've already done that. Although, again, it would have been fair for me to give you the expanded form and you factor back. But so far, so good. We don't have to do long division. We don't have to factor the bottom. But then here's where it gets harder. What is the PFD form? Now, don't worry so much about the top. That could have been a 1 just as well. This thing is bottom heavy. This could have been a 1 just as well. When it comes to figuring out the PFD form, we have here repeated or powers of a quadratic factor that is prime over the reals. This quadratic has no real zeros, x squared plus 1. What is the form? It's going to be what fraction plus what fraction? Two hints. Hint number 1, you want to run up to the power in these denominators. And that's a square over here. So we have 2 fractions. On the top, because we're dealing with powers of a prime quadratic over the reals, up here in the tops, we are going to need linear forms. Think slope-intercept form. Write out the PFD form. All right. Here it is. So we run up to the power. In the denominators, we have x squared plus 1, all to the first, basically, and then x squared plus 1, all to the second. If that were a cube over there, we'd need another fraction that looked like these guys, with the cube on the bottom. And in the top, we need linear forms. Remember, slope-intercept form was y equals mx plus b, right? So these tops are going to look like the mx plus b. A number times x plus a number. ax plus b. Over here, cx plus d. Your friend could switch the denominators, that's fine. Here, I run up to the power. Next, in step 4, we need to write the basic equation. So we need to multiply both sides by the LCD, which is going to be the denominator, the bottom, on the left side. Now, when you multiply this fraction on the left by its own bottom, you're left with the top. So the left side of the basic equation will be the top, the numerator here. Let's focus on the right side because a lot of students make mistakes on the right side. You're multiplying these 2 fractions by this LCD. Do it. I'll give you 20 seconds. Try to write the right side of the basic equation. All right. So again, on the left side, when you multiply a fraction by its own bottom, you get the top. Make sure not to miswrite the top. 2x cubed minus x squared plus 2x plus 2 equals, okay, we're multiplying this fraction. We're multiplying this fraction by x squared plus 1 all squared. So we're multiplying this fraction by 2 copies of x squared plus 1. When we do that, well, one of these cancels out with one of these, but one of these factors still remains. So we have an x squared plus 1 factor still remaining up there. And we multiply that factor by the ax plus b. But remember, folks, you need grouping symbols. You're multiplying all of ax plus b. Remember, the fraction bar implicitly groups its top and its bottom. Here we didn't need the parentheses so much. Here we need the parentheses. It's the quantity ax plus b times the quantity x squared plus 1. You need parentheses around both these factors. Plus, then when you multiply this fraction by its own denominator, you're left with the numerator. Here I put parentheses, but since there's a plus sign in front and it's just this guy, right, then we didn't need the parentheses here so much. Still, I wanted to play it safe. Plus the quantity cx plus d. But watch out. A lot of students make mistakes with this part over here. You need grouping symbols. Now, we need to find the values for the 4 unknown parameters, which are a, b, c, and d. And on homework and exams, if I ask you to write out the PFD, not just the PFD form, I won't go further than D. Okay, so at most 4 parameters here to solve for. Now, before, we relied heavily, or we at least started with method 1, where we plugged in convenient values for x. But here, there are actually no super convenient real values for x. And that's unfortunate. Now still, in principle, you could pick 4 real values for x, plug them in, and you'll get a system of 4 linear equations in 4 unknowns. But you run the risk of that system being a bit uglier than you'd like. Well, as it turns out, if you play it straight, that system may not be too bad, actually. But it could be worse than you need it to be. So here, I think I'll actually start with method 2. We're going to go all the way with method 2. We're going to start off straight up with the algebra. We're going to distribute like crazy here, do the FOIL thing, right? And we're going to combine like terms. And we're going to match coefficients. So we're going to start with method 2, the matching coefficients method. Although if you love method 1, you could do it that way, but be prepared to solve a system that's a bit bigger and more complicated than you might like. All right. So, well, go ahead and do it. Give you 20 seconds. Foil this thing out. Okay. Ax times x squared is ax cubed. Ax times 1 is ax. B times x squared is bx squared. And b times 1 is b. And then you have these guys here. Bring it all together. All right. So we have on the left that original numerator, 2x cubed minus, I went ahead and put in a 1 here. Minus 1x squared plus 2x plus 2 equals, again, ax cubed plus ax plus bx squared plus b from the foiling, plus, don't forget, the cx and the d. So we have a bunch of terms on the left, a bunch of terms on the right. Now, combine like terms on the right, figure out the coefficients on the left, match the coefficients, and actually you are going to get a system of 4 linear equations in 4 unknowns, but this system is going to be very sparse. There are lots of missing spaces in there, and it's going to be actually very easy to solve. Probably easier than the system you would have gotten if you had just plugged in numbers. All right. I'll give you 20 seconds. Combine like terms, match coefficients. I'll give you 10 more seconds to match the coefficients. Write a system of 4 linear equations in 4 unknowns. In fact, I'll give you 20 more seconds. Okay, let's try to get some good form here. On the left, I want to clearly indicate the coefficients in parentheses. 2x cubed is 2 times x cubed. Now here, I want you to be very careful. Minus 1x squared. Remember, the coefficient on x squared is what? It's going to be negative 1. So it's actually better to write it as plus negative 1 times x squared. Because when we match up the coefficients, right, we're assuming that there are plus signs in front, and then the good stuff is in the parentheses, right? So we want to match up the contents of these parentheses here. And we don't have to worry about the fact that we have plus signs out here. If you see a minus 1x squared, make it plus a negative 1 times x squared. In general, if the coefficient is negative, okay, put the plus sign there, put the negative sign inside here, so then you can match automatically. Plus 2x, that's plus 2 times x, plus, well, 2 is 2. So aside from this whole plus negative 1 issue, well, plus negative 1 times x squared, we should be okay on the left. Now on the right, what's happening? Let's say we go in descending powers of x, which makes sense because that's what the left side is like, right? I would recommend going in descending powers of x, get a nice pattern. On the right side, the leading term is ax cubed, a times x cubed. In fact, I'm going to check these off as we get done with these. All right, so we have ax cubed. And then we have only one x squared term, bx squared, plus b times x squared. Plus, now we have ax and cx, right? ax plus cx. What's ax plus cx? Ax plus cx is going to be the quantity a plus c times x. So if you believe that, for example, 3x plus 4x is 7x, 3 plus 4 all times x, then you should believe that ax plus cx is the quantity a plus c all times x. It's like we're grouping these and we're factoring out the x. Plus, let's pick up the constant pieces. We have the b and the d, plus, I'll put this in parentheses, b plus d will represent the constant term. Actually, it's going to end up being the 2, right? We're saying that b plus d is going to end up being the 2 over here. So these coefficients here are all in parentheses, and some of them have more than one term in them. But each of these coefficients will represent a real number. Okay, now we're going to match the coefficients, and we're going to get a system of 4 linear equations in 4 unknowns. So let's match them up. All right, so we start with, in fact, which order do I do them in my notes? Oh yeah, I just, I go from right to left. Actually, it goes through more, it goes through nicely that way. All right, the coefficient on x cubed here equals the coefficient on x cubed here. We're matching the coefficients on x cubed. A equals 2. That's how I got that thing, A equals 2. And then we match up the coefficients of x squared. B equals negative 1. You can see the benefit of just matching up the contents of these parentheses. we can now take it for granted that there's a plus sign in front. We made it so. Whereas if you had put minus 1 times x squared, oh, you could have easily made a sign error. Plus, we match the coefficients on x. as plus c is equal to 2. Finally, matching up the constant terms, you can think of the group B. You can think of the group B plus D as a term in some sense. Bottom line, B plus D equals 2. I guess that's red again. How about green? B plus D. Whether you think of this as one term with the parens or 2 terms in here, whatever. B plus D equals 2. All right. So we match. Do this in black. Again, A equals 2, B equals -1, A plus C equals 2, B plus D equals 2. Oh, okay, well, when you do that, we get a system. I'll write it out. Type it out. Okay, here's a system. If you go right to left, A equals 2, B equals -1, A plus C equals 2, B plus D equals 2. We have a system of 4 linear equations in 4 unknowns, A, B, C, and D. But you can see it's a very sparse system. By the way, some people line up the like terms, but you can see it's a very sparse system, and it's very easy to solve. Right off the bat, A equals 2, B equals -1. We practically get those for free, right? And then, now with these guys here, it's not that hard because notice we have A plus C equals 2, but now wait a minute. Wait a minute. We know that A is 2. Use that. Use that. So yeah, A plus C equals 2, but wait, A equals 2. A plus C equals 2, but wait, A is 2. So therefore, C equals 0. That's the work here. A plus C equals 2, but we knew A was 2. Whoops. We knew A was 2. Plug that in. We get C equals 0. All right. And over here, very similarly, B plus D equals 2. B plus D equals 2. But wait, we know that B is -1. B plus D equals 2, but we know that B is -1. Add 1 to both sides, D equals 3. D equals 3. All right. So we use the top 2 equations here to help us solve these last 2 equations here for C and D. All right. A equals 2, B equals -1. We get, again, A equals 2, B equals -1. We then get C equals 0, and then D equals 3. We're not done yet. Plug in. Oh, well, here's the system we are solving, right? But it's a very sparse system. So this big ugly guy here, right? This is the PFD form, all right? And remember, we got A equals 2, B equals -1, C equals 0, D equals 3. All right. 2, -1, 0, 3. So if you plug in these values for A, B, C, and D, you get this. What does that top become? 0x plus 3. Just plain old 3. And we're done here. We didn't do any long division, so we didn't have any extra pieces over here, like that x minus 1. This is it. Of course, you can switch the fractions. 2x minus 1 over x squared plus 1 plus 3 over the square of 3x 3 over the square of x squared plus 1. Partial fraction decompositions. That's it. Get practice. Here's the deal with PFDs. It's like sticking your feet in the cold water. You get very shaken at first, and you might freak out at first, but people get really good at these. So by the time you do like problem Z on my homework, I'm not really kidding that much. By the time you get through problem Z on my homework, you'll get a good feel for partial fractions. In fact, you might have more trouble reviewing the factoring along the way from chapter 2, right? Like 2.5. But you get good at this by the time you get to problem Z. On the final, on the Math 141 final, people normally do very well on these PFD problems because they get so much practice. They're good students, they get lots of practice, and they do these well. And they don't forget their grouping symbols. Good luck. A bit more in chapter 7 next time.